Hi everyone. Today we're going to talk about section 4.5 again. However, instead of the letters A and B, we are going to talk about the letters C and D and how those are going to contribute to our graphs. Alright, we're still going to be graphing sines and cosines, so keep that unit circle handy. Get it out if you need to. Help you with some values here. We're going to take the information from last class regarding A and B, so we will need that information. If you haven't watched that video or gone over those notes, please make sure you do so prior to watching this video. And then we will take that information and keep applying it to letters C and D. All right. So what we have for letter C in the first section of notes here is we're going to have a phase shift. And it's just like the common shifts that you guys are used to when we talked about quadratics back in Algebra 2, when you talked about linear functions or even absolute value functions in Algebra 1, how things shift from left to right or even up and down. Okay, so when we talk about the letter C is going to phase shift our directions to the left or to the right. That is what C is going to do. So, before we get started, we have this new function. So it's very similar to last class, except now we're introducing the letter C. And what I want to point out before we get started is that notice B is inside of that parentheses, okay? Last time we didn't have a B inside of the parentheses, and I want to keep it that way. So to get started, I want to remind us or get us thinking that we need to first factor out our B. And the reason we want to factor out our B is because B is going to help us find our period. So that is why we want to factor it out. Because once we know what our true B value is, then we will know our period. So we want to factor out B first to help identify our period. And remember, period is how many times or how long it's going to be before it repeats itself. Okay. And as a quick reminder, the letter A was our amplitude. B goes with my period, remembering that function 2 pi over B to find your period. And then C is going to relate to my phase shift. So the new thing for today, C refers to my phase shift. And our options for that will be left or right. Left when it's negative, right when it's positive. All right. And the other thing I want to point out too is if you look at the letter C in that function, there's a negative or a minus sign in front of it. So that is going to play a role as well. So keep in mind that your C value is going to be the opposite of what you see. All right. Much like your H and K value, your H value was opposite of what you saw every time when we talked about quadratics in vertex form. Okay, it's the same idea. It's got to be opposite because there's a negative with it. And the last bit of information right here tells you our starting point is going to be shifted from our normal x equals 0 to C over B. All right, this is important. However, if we do this first step up above where I told you to factor out your B first, you don't necessarily have to worry about C divided by B because you will see what this phase shift or how it's going to be shifted and where your starting point will occur. So don't worry so much about that last section there. We will get started on some problems and you'll see kind of how that relates to everything. So to get started, we're going to do the same things we did last class. We're going to label our A, B, and C. We don't know D yet. We will talk about that in the next section. Okay, but before we get started, remember our first step is to factor out our B. So right now, my B looks like it's going to be a 2. It's that number that's right in front of the x every time. So if I want to factor that out, that's going to give me y equals 4 sine, and I'm going to take the 2 out, leaving me with x minus, and if I take a 2 out of the second term, that's going to take my numerator away. And so that leaves me with pi over 3. If you want to do a quick check, if you take that 2 and distribute it back in, you should get the same exact function we started with. All right, so if you ever struggle with factoring that out, that's always a good easy check. If you distributed it back in, you get the same thing. Okay, so now with that factored out, let's find our three things. So my A value is going to be 4. My B value is 2. And then your C value, remember, it's always the opposite. So right now we see a minus pi over 3, but I actually want the positive. So that's going to be a positive pi over 3. Thinking about what my graph is going to do now, before I even get started on making my picture, I know that my height from the center of my line, my sine squiggly line, is going to be 4. My period, based off of the fact that my B is 2, my period will now be 2 pi over 2, which is just pi. We'll get back to that in just a second. And then because my C is positive, C is going to tell me that I'm going to go right pi over 3. All right, so with that information, my amplitude is going to be 4. My period is going to repeat itself every pi length, and then I'm going to now start at pi over 3 on my graph. That is what all that information is going to tell me. So let me scroll down here and give myself some room. So let's start with amplitude. We know our amplitude is 4, so that tells me that my maximum will have to be a positive 4, while my minimum is going to be a negative 4. There's no changes up or down that's going to affect my height. Our period we just found was pi. Okay. But if I want to figure out what values I need on that line, I'm going to take that pi and I'm going to divide it by 4. So I want to have points at every pi 4th length. That's what that is telling me to do. That's why we divide it by 4, so that I can find key points along my XY axes. And last but not least, our starting point. This is new to us today. Our starting point is going to be at pi over 3. Whatever our C value was when we took it out, that is going to be our starting point. Okay? So with all that information, let's go ahead and draw a graph. I'm going to stick to the right side. So I'm not going to draw all 4 quadrants. I'm just going to draw the first and the 4th here, if you really think about it. My height is going to be a positive 4, so I'm going to mark off a positive 4 as well as a negative 4. And then I want to start at pi thirds, because that was my phase shift. So that's going to be my starting point. And now, with my starting point at pi thirds, we can make a little XY table here to help us, if we need it. I'm starting at pi thirds, and I want to go every pi 4ths after that. So if I think about that, if I got pi thirds for starting, and the next point I want to be at an additional pi 4ths, I need to get the same denominator, fix the numerators. So my next value will put me at 7 pi over 12. There's no negative there. Okay, so that's the next value, 7 pi over 12. These are going to get kind of funky here, but as we work through them and as you see the patterns, just like last class, you'll see kind of how it works. The next one, if you continue that to figure out all 4 of your values here, the next one will be 5 pi over 6. If we add another pi over 4, that puts us at 13 pi over 12. Try to reduce your fractions as much as possible when you can. And the last point, we will call it 4 pi over 3. Again, I'm just adding pi 4ths to each one of those. Just make sure you have the same denominator when you add them together, and then you can simplify from there. And then if you take your calculator, or you can do this by hand as well. If I do pi thirds, I'm going to plug in a pi thirds for x. And if you happen to do this in the calculator, remember your x values are actually radians. You're in terms of pi. So this is where you will need your calculator to be in terms of radians. I talked about that before where we have to swap back and forth. This is when we would want it to be in terms of radians because our angles are in fact in radians. Okay, that is one reason why we would want to use radians. If you use degrees, it's going to give you weird decimals. It's not going to be exact answers. So if I think about this and I'm doing it by hand, well, pi thirds minus pi thirds in parentheses is just going to give me 0. 2 times that 0 is still 0. So I'm looking at 4 sine at 0. Take a look at the unit circle. Well, sine at 0 is going to be 0. And then times 4. There you have it. We got a 0. So at our starting point at pi thirds, we want to be at 0. The next coordinate is going to put us at 7 pi over 12. Finish labeling these here for me. And 4 pi over 3. Okay, if I plug in a 7 pi over 12, that's going to make me replace this inside value here. 7 pi over 12. Get a common denominator. So that's going to leave me 7 pi minus 4 pi gives me a 3 pi over 12. Well, 3 pi over 12 simplifies to just pi over 4. Bring down the 2. When I multiply 2 times pi over 4, I'm now looking at 2 pi over 4, which simplifies to pi over 2. Bring down my sign and multiply it by 4. Again, you can do this in the calculator if you need to. Just make sure you're in terms of radians on the calculator. Sine at pi halves now is going to be a positive 1 times 4. So we're looking at, that was not a good 4. We're looking at positive 4 there. Once we know a value, let's go ahead and plot it on the graph. And just like last class, you guys started to see the patterns developing. So I would venture to guess that at 5 pi over 6, you're probably going to get a 0. You can test the math, you can use the calculator if you'd like, but you will indeed get a 0. Following that pattern, you got everything above the x-axis, so now we need everything below, which means the next point is going to be at negative 4, followed by 0. Okay, and again, I just need one period here. I don't need constant repeats, just one period here, one length. So we got this little loop here, followed by that loop there. And of course, adding your arrows at each end. All right. One thing I don't know if I really touched on last class or not, but it got me thinking today in class. For pi thirds, remember that was our starting point. And our period told us that we had to end and start our repeating every pi. So take a look at your last value. Our last value was at 4 pi over 3. Well, how far was that distance? If I had pi thirds and I went all the way to 4 pi thirds, you did a difference of 3 pi thirds. Well, 3 pi over 3 gave us just pi. That just so happens to be the period. So that's another way for you to recognize your stopping point, is this is your start. And then you're going to use your period to find the remainder to get to the end. Okay, so that's another idea to help you with determining those points. And then from the beginning to the end, you need about 3 more points. Hence why we divided by 4, because in total, we wanted 4 points to get to the end of our period. Okay, I didn't quite touch on that last class, so I want to make sure I touch on that this time. So let's do question 2 together. This time we have negative 3 over 2 cosine of 2x plus pi. All right. Don't let those fractions scare you. We can do them just fine. Let's start by first factoring out our b value. So we're going to take out that 2 in front of that x. So that's going to give us y equals negative 3 over 2 cosine of 2 parentheses x plus, and then if you struggle with figuring out that last value, you're always dividing that pi or that radian by whatever you just took out. So if I just took out a 2, then I'm going to put that 2 in the denominator. And again, if you want to check, you can take that 2, distribute it back in, and it should put us right back at the beginning of what we had. Okay? If you ever question it, just check it. That's not a big deal. Now that we have the 2 factored out, let's go ahead and identify my a as negative 3 over 2. My b is going to be 2, and my c, remember c is always the opposite of what you see, and you want a negative this time. Thinking about what that means, well, this one tells me that my amplitude is negative 3 over 2, therefore my max, and actually when we do amplitude, remember it's just the positive version, so it's just a positive 3 over 2. Take the absolute value of it. My max will be 3 over 2, while my min will be a negative 3 over 2. Our b value, well, b is going to tell us our period. So that's 2 pi over 2, which happens to be pi again. And since we're here, let's go ahead and take that pi and divide it by 4 so that we know our points want to occur every pi fourths. And last but not least, c is a negative, so that's going to tell us we need to go to the left pi over 2 as our starting point. So we've already identified our max and our min. We know our period is going to be pi. Well, if I divide that by 4, then all my points need to be separated by exactly pi over 4. And my c is going to take me to the left pi over 2, so that means that my starting point, since I'm going to the left, is going to be at negative pi over 2. So when I go to make my picture, I do actually want to start on that left-hand side, and then I'm going to move over to the right-hand side. All right, so I'm starting at negative pi over 2. I know that I have to go at a full length of pi. Well, if I have negative pi over 2 and I add a full length of pi, that's going to put me at a positive pi over 2. And then you can find the marks in between, or we can use this little handy dandy trick that I showed you. Just go every pi fourths. So if I make my XY chart here, I'm starting at pi over 2, negative pi over 2. If I take negative pi over 2 and I add pi over 4, because that's the next length that I need, get the same denominators here. That's going to put me at negative 1 pi over 4. Well, that's the next one. Just so happens if I add another pi over 4, well, that's going to put me at 0. Followed by pi over 4, ending with a positive pi over 2. So those are going to be all of my marks. 0, and then pi over 2. I didn't really do this well to scale here, so I'll fix that up. Positive pi over 4, pi over 2. There we go. That looks better. And then our amplitude is going to be 3 over 2. Well, if we think about that, that's going to be in between 1 and 2. So I can label it. If you want to go straight to just 3 over 2, that is fine as well. I just want to give a different picture, I suppose. Now we need to figure out what these coordinates are. So if I take negative pi over 2 and I plug it in, it's a lot easier. If you ask me, it's a lot easier if you plug it into the factored form, just because that starting point is going to get you a 0 every time, which is nice. So negative pi over 2 plus pi over 2 gives me 0. 0 times 2 is going to give me 0. So I go and I ask, well, what's cosine at 0 multiplied by negative 3 over 2? Well, cosine at 0 is 1. Multiplied by negative 3 over 2 is a nice negative 3 over 2. So at negative pi over 2, I want to put a point at negative 1/2. If I did that same thing, but this time plugged in a negative pi over 4, well, negative pi over 4 plus pi over 2, if I made that there and change that there, that's going to give me a positive pi over 4. Multiplied by the 2 out front gives me a pi over 2 when I simplify. Well, cosine at pi over 2 multiplied by negative 3 over 2 will give me a 0. So there's my coordinate. Keep on going. If you plug in a 0, 0 plus pi over 2 gives me pi over 2. Pi over 2 times 2 will give me a nice pi. Well, cosine at pi is going to give me negative 1. Negative 1 times negative 3 over 2 gives me a positive 3 over 2. And again, I'm doing a lot of this in my head, but if you need the calculator or you need to write it out, please do so. Get a scratch piece of paper next to you and work it out if you ran out of room. Whatever you need, please, please, please do that for yourself. All right. When I plug in a pi over 4, that's going to bring me right back to 0. And when I plug in a pi over 2, that's going to put me back at negative 3 over 2. Connect all my dots here. It's a little bit different of a graph, kind of like a bell curve. And don't forget your arrows at the end. Okay, so the only difference from last set of notes to this set of notes is we're introducing left and right phase shifts. So I'll do one more with you guys. I am going to skip 3 just because I want to practice the factoring a little bit more. So 3 you can find on my teacher notes. All right, so go ahead and do that and practice, and you have my answers posted on Teams if you need them. Question 4 I will do with you. Same idea. I want us to first factor, label my A, B, and C's, and then we can go from there building our graph. So if I factor this time, I'm still going to take out that 2. So that gives me negative 2 sine of 2, and back in parentheses is going to give me an x minus. And remember, whenever you factor something out, we're going to throw it in the denominator. So for this pi over 3, I already have a 3 in the denominator, but if I'm now going to introduce the 2 in the denominator as well, I want to multiply them together. So I'm still going to have pi up top, but down below, when I took that 2 out, it's now going to change that 3 into a 6. Again, if you want to check, just redistribute that 2 back in. Make sure that it stays as pi over 3 like we just had. Okay, you can totally do that. So that gives us pi over 6. Now let's find my A, which is negative 2. My B is 2. And my C, again, opposite, remember opposite, is a positive pi over 6. Take that information, now let's put it on a graph. Bring it to a graph. My amplitude is going to be a positive 2, which means my max will be at 2, while my min will be at negative 2. My B is 2, which means my period will be at 2 pi over 2. Simplify that, and I will get pi. But I know that it needs to occur every pi fourths. I need a point. And last but not least, for pi over 6 for c, that tells me I need to go to the right pi over 6. Therefore, my starting point is going to be on the right side at pi over 6. Go ahead and make my graph. I'm going to be on the right side this time, so I don't need anything on the left. Make my XY table if I need it. Starting at pi over 6. And I'm going to add pi over 4 to get everything else. So point 2, third point, fourth point, and the fifth. Okay, so I'm starting at pi over 6. If I add pi over 4, get the same denominators, so they share 12. That's going to give me 5 pi over 12. That's my next point. If I continue adding pi over 4, if I add another pi over 4 to this, get the same denominator, that's going to give me 8 pi over 12. Of course, we can simplify that. Always simplify it when you can. So if I divide it by 4, that's going to give me 2 pi over 3. If I add another pi over 4, same denominator. This will change to an 8. This will change to a 3. That gives me 11 pi over 12. And then last but not least, you should be at your final point. Well, our final point should be exactly a full pi later. So if you add a pi to pi over 6, that will put us at 7 pi over 6. And if you don't believe me, let's take that original 11 pi over 12 and add another pi over 4. Get the same denominator. That gives me 14 pi over 12. They both have a 2 in common. So I can take that out from top and bottom, and there we have it. 7 pi over 6. All right, now that we have our points for my x's, let's go ahead and find those coordinates for my y's. If I plug in a pi over 6, again, use the form that you just factored. It makes things a lot easier. Pi over 6 minus pi over 6 gives me 0. 0 times 2 gives me 0 again. Well, sine at 0 gives me 0. Times negative 2, still at 0. 5 pi over 12. Plug that in. Get the same denominator. That's going to give me 3 pi over 12, which is technically pi over 4. Pi over 4 times 2 gives me pi over 2. Sine at pi over 2 is 1, but multiplied by negative 2 gives me negative 2. Oh yeah, I forgot my amplitude, guys. So we should have a height of 2 on either side so that I can label my coordinates as such. And again, once you see the pattern, I bet if you plugged in a 2 pi over 3, you would get 0. If you plugged in 11 pi over 12, you would get 2. And if we plugged in a 7 pi over 6, we would get 0 as well. Connect the dots. Add your arrows. And you're all set. And there's your graph. So question 3 we skipped. Go ahead and try that one on your own. You have my teacher answers for you. Same goes for question 5 and question 6. Question 5, actually looking at that, that's a nice one. It's already in the form. You don't have to factor out anything because that number in front of your x is 1. So 5 is ready to go. You don't have that factoring step necessarily. Okay, but make sure that you still identify that your b is indeed 1. So my teacher notes are posted on Teams. Go ahead and look there to check your answers. and we will get started on section 4.5D. Okay. If you want to do questions 3, 5, and 6 right now and pause the video and practice it on your own and look at my answer key, by all means, please do so. Otherwise, you can keep on going. Okay. So this one is the same idea. We still have A means the same thing. We still have B means the same thing. C means the same thing. Now we're going to introduce D. Okay. So at the end of this entire section, I want you to know 4 things. All right. A is always going to refer to our amplitude. Amplitude meaning our height. B is always going to go with your period. So I'll say it helps us with the period, which is 2 pi divided by B every time. C, which was just introduced, is my phase shift, which means I'm either going to go right or I'm going to go left. Left when it's negative, right when it's positive. And last but not least is D. And D is going to be a phase shift as well, but this time it's going to be a vertical phase shift, meaning you're going to go up or you're going to go down. Up when it's positive, down when it's negative. All right. And the last thing I want to point out is the difference as soon as we start working with these examples, especially number 1, all right, the letter C is always in parentheses. Okay, so if you don't see parentheses, then there's no letter C. We can assume that that letter is going to be 0. And I want to introduce that because in question 1, we're going to have to use that fact. All right, so just keep in mind that C will always be in parentheses. And if you obviously don't see parentheses, then your C is going to be 0. So this time, how will D play a role in our graphs? Let's find out. Okay, we know D is going to be a vertical shift. It's actually going to affect my graph either up or it's going to affect it going down. And if you think about that, the only thing we've talked about yet so far is my amplitude in terms of my height, in terms of anything that's going up or down. So the only thing that D is going to affect is my amplitude. So we have to keep that in mind as we go through these examples. All right. If you have a D value, it will affect your amplitude, and I will show you how. So to get started, we have y equals cosine x minus 1. We don't see any parentheses, so we don't need a factor for this one. So let's go straight into identifying my A, my B, C, and D. We have all 4 letters now, so let's label each of them. My A, your number out front of your cosine, well, we don't see a number, so we're going to assume it's a 1. Cosine of x, well, there's your B. It's in front of your x every time. Well, we don't see a number in front of x, so we assume again that it's 1. C is always going to be in parentheses. Well, if we don't see parentheses, this time it's not going to be 1. It's going to have to be 0. And the reason for that is because C is always getting added or subtracted. Well, if you don't see anything that's being added or subtracted in parentheses, then the only option for that is 0. Okay, when you add things, if it's not there, then when we add or subtract, it has to be a 0. And last but not least, the D value is going to be at the end. And since there were no parentheses, we know that that minus 1 is going to be that value. Okay, and yes, we will take it as is. The only thing that comes out as the opposite is our C value. Okay, so make sure that minus does come with the 1. So let's go through what we know. Well, if our amplitude is 1, it still means that our height from the middle is going to be 1. All right, but now our max and our min are going to be affected. So let's start with what we know. Originally, we would have said our max was 1 while our minimum was -1. Well, now we have to take our vertical shift and we're going to take it exactly as it was, and we're going to subtract 1 from both our max and our min. So my new maximum is going to be 0, and my new minimum is going to be a -2. We will see how that plays out here in just a moment. My b is 1, so that's going to tell me that my period is 2 pi over 1, which is just 2 pi. So when I go to make my picture, I want to go every fourth of that, so that's going to be every pi halves if I simplify that. My c is 0, so there's no left or right, which means my starting point is going to be at 0. We just talked about that. And last but not least, letter D is going to tell me that I need to go down 1. And we just introduced that because we know my max and my min is going to take me down 1. All right. Make our XY table if you need it. We're going to start at 0 because my C value was 0. The next point, I want to go every pi halves, so the next one would be pi halves. The next pi half from there would be pi. Next pi half would be 3 pi over 2, followed by 4 pi over 2, which is just 2 pi. And there we go. We have our full period. Go ahead and make my graph. I only need the right side of the x-axis. For this one, we know our amplitude is 1, so we're not going to label it as 1 and -1. We are actually going to label our max and my mins, our new max and our new mins. So I want a max at 0 and a min at -2. All right. Go ahead and label my x-axis here, pi over 2, pi, 3 pi over 2, 2 pi. Now let's find our values. If I took 0, plugged it into my function, okay, you're not doing this together. They are separate terms. You need to first find cosine at 0 and then subtract 1. So you need the unit circle first. Cosine at 0 is 1. Then I subtract a 1, so that puts me right back at 0. Okay? So my first point is at 0, 0, right on the origin. Next one, pi halves. Well, if I plug in a pi over 2 for my x, cosine at pi over 2 is 0. Minus 1 gives me -1. At pi, cosine of pi is -1. Subtract another -1, or excuse me, subtract another 1, and we get -2. Cosine at 3 pi over 2 is 0. Minus 1 gives me -1. And cosine at 2 pi is a positive 1. Minus 1 again gives me 0. Graph my lines here. Okay, so take a look at this graph and compare it to the other ones we've done in the past. We actually don't cross the x-axis, and the reason we don't is because my maximum was 0, while my minimum was -2. So the highest point I can go for my y is 0, and the lowest point I can go for my y is -2. That's how that max and min is going to play a role. Now, if you're getting stuck remembering and thinking of, well, my amplitude was 1 and I don't see a 1, okay? Remember, your amplitude is the distance from the middle of the graph. So if I were to go from the middle of the graph and I were to go up, well, from the middle to the top, my max, I do actually have a distance of 1. Similarly, if I went from the middle down to the bottom, my minimum, I would also have a distance of 1. Okay? That is what your amplitude is telling you. It's the height from the middle of your graph up to your min and then down, or up to your max, then down to your min, right? So if you're getting confused, that is the simplification of that. That's the justification. So let's practice question 2. Same thing. If we have a b value, let's factor it out. Question 2 doesn't have a b value, so we are good to just start labeling. All 4 letters now. We've learned all 4, so let's start labeling all 4 from here on out. If there is nothing, that's fine. We'll just move on. My A is 3. B will be 1. There are no parentheses, therefore there is no C. That means it's 0. And D is going to be a positive 2. Thinking about how this will play a role, my amplitude will be 3, which means originally my maximum will be 3, while my minimum will be negative 3. Now I say that's my original because something's going to change it here shortly. B is 1, so that tells me my period is 2 pi over 1, so just 2 pi. If we divide that by 4, I want to go every pi over 2 when I simplify that. C is 0, so I have no changes left or right. And D is 2. Well, D tells me I'm going up or down, but in this case I'll go up 2. So what I want to do now that I've identified that D is 2, I want to take that positive 2 and I'm going to go back to my max and my min and add that positive 2 back, because now I have a new max and I have a new min. So my maximum will be at 5, while my minimum is now at negative 1. All right. Go ahead and make my picture here. X, Y. Again, if you need it, your starting point is still at your C. So we're going to start at 0. Pi halves. Pi. 3 pi over 2. 2 pi. So I only need the right-hand side. Well, my new max is going to be at 5. And my min is going to be at negative 1. So I don't need the amplitude of 3's. I want my new max and my new min. Label my x-axis. And 2 pi. And let's get going. This time we're talking sine. So if I use the unit circle, I'm going to look for my sine values. If I plug in a 0, well, sine at 0 is going to be 0. Times 3 is still 0. Plus 2 gives me 2. So at 0, I want to put a point at 2. Move on to pi over 2 here. Sine at pi over 2 gives me 1. Well, 1 times 3 is 3. Plus 2 is 5. Again, you'll start to see the patterns develop. If I plugged in a pi, sine at pi is 0. Times 3 is still 0. Plus 2 is 2. So that brings me right back down. 3 pi over 2. Sine at 3 pi over 2 is negative 1. Times 3 is negative 3. Plus 2 is negative 1. There we go. That's how we got that bottom point. And last but not least, at 2 pi, sine at 2 pi is 0. Times 3 is still 0. Plus 2 gives me 2. Graph my line. And there we have it. All right. Your amplitude is still 3. Again, if we were to split this graph in half, I would have a height of 3 going up to my maximum and a height of 3 going down to my minimum. Okay, that's the amplitude. That's your height from the center of your graph up and the center of your graph down. That's the distance from your min to your max. All right. I will do question 3 and then leave you guys to finish 4, 5, and 6. So question 3 actually introduces all 4 letters this time. Instead of having 0 for C, we are actually going to have a value. So we need to start by factoring. Just like in the last section of notes, we have a b value. It is in that parentheses. We need to get that out. It is attached to x. So before we factor, what I want you to realize is that this is saying 4 cosine of 1/2 x plus pi minus 6. Okay, that x over 2 is really just 1/2 times x. So that when we go to factor out our b value, we know that we need to take out a 1 over 2, and the x will stay. All right. Now remember, I told you whatever we take out, we have to put in the denominator. So think about it for a second. If I had pi originally, and I just took out a 1 over 2, that doesn't mean it's going to be pi over 2. That means we now have to skip the first fraction, flip the second fraction, and multiply. So that's really going to give me a 2 pi. So our c value is actually going to grow. Don't believe me? Distribute. Practice it. See if it works out. If I took that 1/2 and multiplied by 2 pi, that will indeed get me that pi right back. All right, so think about that. Use our rules in math if you need to use that check method. And the 6 is unaffected. Okay, it wasn't part of the parentheses, so it's not going to be affected at all. Now that we have my b value factored out, let's go ahead and label all 4 things. My a is 4, b is going to be 1 over 2. C is always opposite. Don't forget that. C is going to be a negative 2 pi over, 2 pi, negative 2 pi. And last but not least, D will be negative 6. Think about how this plays a role. My amplitude is 4, which means currently my max will be 4, my min will be negative 4. My B is 1 over 2, which means my period is going to be 2 pi over 1 over 2. Skip, flip, multiply. And when I do that, my new period is actually going to be 4 pi. Keeping that in mind, I want to go every fourth of that. So I'm going to be going every pi on my graph. C is negative 2 pi, so that means I want to go left 2 pi. So my starting point at negative 2 pi, that's going to be on the left side. And then D is negative 6. Well, because it's negative, that tells me I need to now go down 6. But before I go to make my graph, I need to take that information and apply it to my max and apply it to my min. So if I subtract a 6 from both, I'm going to get a new maximum at negative 2, and a new minimum at negative 10. So this kind of helps you with your sketch before you get to the sketch, because now we know how it's kind of going to be looking. Since my max and my min are both going to be negatives, I can graph something that will look like this. If I want to give myself plenty of room along the y-axis, I can make it look something like this. That way I have lots of room to mark my y values that are negative. Okay, so there's negative 2 and negative 10. Go on my x-axis. If I want my t-chart here, I can make one. I'm going to start at negative 2 pi. Good thing I gave myself some room here. If I add the next pi, that puts me at negative pi, then 0, then pi, and then 2 pi. And in total, that'll be a total of 4 pi. And now we can start plugging our values in. Negative 2 pi, if I plugged that in, cosine of 1/2, negative 2 pi plus 2 pi minus 6. This gives me a 0, Well, 0 times 1/2 gives me 0. Cosine at 0 is 1. Don't forget, we're still multiplying by 4 and subtracting 6. Remember your order of operations. Do your multiplication first. 4 times 1 is 4. Minus 6 is -2. So at -2 pi, I want to be at -2. At negative pi, if I plugged that in, negative pi plus 2 pi gives me positive pi. Positive pi times 1/2 gives me pi over 2. Cosine at pi over 2 is 0. 0 times 4 is 0. Minus 6 is -6. 3, 4, 5, 6 right here. If I plug in a 0 this time, 0 plus 2 pi is 2 pi. 2 pi times 1/2 is pi. Cosine of pi is -1. -1 times 4 is -4. Minus 6 is -10. All right, I'm doing all of this math in my head. If you need to write it out again, please do so. I'm doing all these steps for each value I'm plugging in. Okay, so for -10 at 0, there we go. Followed by pi. Pi plus 2 pi gives me 3 pi. 3 pi times 1 over 2 is 3 pi over 2. Cosine at 3 pi over 2 is 0. 0 times 4 is still 0. And 0 minus 6 is still -6. So at pi, I want to point at -6. And last but not least, 2 pi. Plug that in. 2 pi plus 2 pi is 4 pi. Times 1/2 gives me 4 pi over 2, which is just 2 pi. Cosine of 2 pi is 1. 1 times 4 is 4. Minus 6 is -2. And there we have it. Connect all your dots here. Make sure it is coming back down with your arrows because it's not going to keep shooting up. And the graph represents the same idea. If I were to split it in half, my amplitude should be 4. The distance from the center to the maximum should be 4. So we just went from -6 up to -2. That checks out. And same thing for going down below. If I go from -6 down to -10, I should have an amplitude of 4 as well, and I do. All right. So we're just practicing. You will have your homework posted to Teams. When we get to taking the final, however, if you take a look at questions 22, 23, 24, and 25 on your final review study guide, those questions are directly related to everything we did today, as well as the last section of notes. All right. So those are what I need you guys to interpret and be able to do on your final. What's the phase shift? What's the amplitude? How about the period? And then is it vertical shift or is it a horizontal shift? And how much? Okay, those are the concepts I need you guys to grasp. And we will get more practice next semester doing unit circle interpretation. So make sure you keep that unit circle page handy and keep memorizing it if you haven't done so already. As always, if you have any questions, please let me know. And we are all done.